This is section 10.2, and this is on the quadratic formula. So the quadratic formula is going to be a way of solving a quadratic equation that is always going to work. You know, they don't always factor. Completing the square isn't always nice. The square root property you can't always use, but the quadratic formula, that's your go-to. You can always use that. It will work for any quadratic equation. So remember, a quadratic equation does have a highest power of 2, so it does have this form of ax squared plus bx plus c. Okay? The solutions to this, and this formula comes as a result of some completing the square business. So if you did ever want to see the, where this formula comes from, that's where it comes from. So the solutions, remember there's going to be 2 of them, and it's going to be negative b plus or minus, that's where the 2 solutions are going to come in, the square root of b squared minus 4ac all over 2a. This bit right here, this b squared minus 4ac, that stuff under that radical, has a name. It's called the discriminant. Okay, so this is your quadratic formula. You don't have to memorize this. Okay, you can just keep this handy with you as you work through examples. Okay. Now, what's so special about the discriminant? Remember, the discriminant is going to be that stuff under the square root. The discriminant is going to tell you how many solutions and what those solutions will look like. All right? So we're going to have 3 different scenarios here. If the number under the square root is positive, that's what bigger than 0 means, then you're going to get 2 real number solutions. If the number under the square root is 0, you're going to get 1 real number solution. Now, you may be like, no, you said you always get 2. You do. You get 2 answers. They just happen to be the same number twice. All right, so you get the same number twice. But we say that it's just 1 real number as your solution. It's just repeated. If the stuff under the radical is negative, well, then you're going to be taking the square root of a negative, so you're going to get imaginary or complex solutions. So in Hawks, it's going to give you some examples, and it's going to ask you to go ahead and predict, without actually finishing the problem, to predict the number and type of solutions. So that's why I went ahead and kind of accented this part for you. Number of solutions, type of solutions. And it all comes back to the discriminant. Is the stuff under the square root positive, 0, or negative? Okay, so let's look at this first example. Let's use the discriminant to find the number and type of solutions. So first off, we need to know, what is the discriminant? What number is it? Well, remember that standard form of ax squared plus bx plus c. A is my coefficient of x squared, b is my coefficient of x, and c is that constant when the equation's in standard form. So with that standard form in mind, we can see that a is 1, b is 3, and c is 1. So taking the discriminant, the b squared minus 4ac business, and then just substituting these numbers in for a, b, and c, we get the discriminant simplifies to be the number 5. That doesn't mean there's 5 solutions. You only care about this number, okay? When you, as far as, caring about this number, is this number positive? Is it 0, or is it negative? Well, it's positive. So because it's a positive discriminant, we get 2 real number solutions. So there's the number of solutions and there's the type of solutions. Let's look at another one here. So with this one, pause the video, write out what A, B, and C are, find the discriminant number, and then compare it with the stuff from the previous page. So pause the video and do that. All right, this is in standard form. So we can see that A is 3, B is -1, and C is 2. So when we plug those numbers into the discriminant formula, be very careful because B is -1. You want to make sure that you square that entire -1 number. So -1 times -1 is +1. You subtract and you get -23. That's a negative number. That means, remember the discriminants is stuff under the square root. So you're going to be taking the square root of a negative. You know what happens when you take the square root of a negative, right? Imaginary numbers. Because this is negative, the original equation is going to have two complex solutions. You can say imaginary, either one. Imaginary, complex, those are synonymous. All right, so pause the video and find the discriminant for that equation. So you can see A is 1, B is -8, C is 16. Plugging those numbers into the discriminant, again being careful, making sure you square that entire number, not just the 8, make sure you square the -2. We get 64 minus 64, which is 0. So what that means is we're going to have that -b plus or minus the square root of 0. That means you're going to add 0 and then subtract 0. That's going to give you the same answer twice. So we're just going to get one real number solution out of that. All right, so let's actually use the quadratic formula. Now what Hawks is going to do, it's going to walk you through these. Okay? And it does so that you don't make any mistakes along the way. And if you do, you can fix those. Because like first thing, label A, B, and C. If you label A, B, and C incorrectly, you miss a sign or something, that's going to throw the whole thing off. So Hawks is going to kind of walk you through this, right? So the first part on these, you're going to have to label A, B, and C. Then it's going to ask you to find the discriminant. Remember, that's the b squared minus 4ac. Then, just like the previous examples, it's going to ask you for the number and types of solutions. So you're going to look to that discriminant. Is it positive? Is it negative? Is it 0? Then the last step, we're going to solve using the quadratic formula. Now the nice thing about doing it in steps like this is that once you find that discriminant for step 2, you can go ahead and just plug that number into here. You don't have to redo that computation again. I'll show you what I mean by that. So, example 2, let's solve this. This does not factor nicely, and you can't use the square root property. You could complete the square if you wanted to on this one, but let's use the quadratic formula. So comparing this to the standard form, A is 1, B is -6, C is -1. So because, you know, Hawks is going to guide you through with steps, I'm going to do the same thing. So step 1, ABC. Step 2, find the discriminant. Okay, we're familiar with this. We just did that. This is just a bunch of plug and chug. Remember, B is negative, so make sure you square that entire thing. So we get 40. That is positive. Positive discriminant means 2 real number solutions. All right, so until 1, 2, and 3, those, nothing new. That's exactly what we just did in the last one. So this is the new stuff. Here's our quadratic formula. Now before we go and just start plugging and chugging stuff in there, we are going to still use this A, B, and C. Before we start plugging and chugging willy-nilly here, don't go and plug -6 in for this B and then 1 in for this A and -1 in for this C. You already did this computation up here and got 40. You don't have to redo it again. So you can see how I kind of color-coded that for you. So, okay, -b, negative's part of the formula. B itself is a negative number, plus or minus the square root of b squared minus 4ac, all over 2a. A is 1. Now, I'm going to flip over to the next page, but I'm going to simplify this. But this is just my initial, plug and chug for the quadratic formula. Those two negatives are going to multiply out to be a positive. 2 times 1 is going to be 2. And I'm going to simplify the square root of 40 because I can see that it's got a perfect square factor of 4 to it. So it's going to simplify. All right, so as promised, there's the positive 6 because there was 2 negatives out there. Plus or minus the square root of 40 all over 2. The square root of 40 is going to simplify to be 2 root 10. And I did just kind of do a little happy little thought cloud over there. But remember, if you want to just use your calculator, do that, 2 root 10. So this becomes 6 plus or minus 2 root 10 over 10. This can simplify a little bit more. We can reduce some fractions. So what I did was I broke this up into 2 separate fractions. So I broke it up into 6 over 2 plus or minus 2 root 10 over 2. So because this is 2 fractions that were added together that had the same denominator, I can then split it apart with that same denominator. When I do that, 6 over 2 simplifies to be 3. That 2 and that 2 will reduce to just be 1, which I don't have to write right there. And here's my 2 real number solutions. I got 3 plus root 10 and 3 minus root 10. Those are real number solutions. Now, how do you know they're real numbers? Well, they're not imaginary. Remember, numbers are either real or imaginary. And I didn't take the square root of a negative, so they're not imaginary. Now, some of these answers are going to work out to be really nice. You know, like you might get x equals 6 and x equals negative 4. Some of them, not so pretty. So you got to be prepared for, you know, for all of these. All right, I'm going to start on a clean page for the next one. All right, I'm going to go through the exact same steps again. You should pause the video at this point. Label A, B, and C, find the discriminant, tell me what kind of solutions there's going to be. So there's A, B, and C, 1, 4, and 3. The discriminant is just some plugging and chugging there. We get 4 squared minus 4 times 1 times 3. You can put all of this in your calculator. So if you don't have to do this computation in your head, unless you just want to. 4 is positive. So we get 2 real number solutions. Remember, there's the number, there's the type. Why is that 4 circled in red? Because you don't have to recomputate it. I don't know if that's a word. Recompute it? Yeah, that sounds better. Yeah, we'll go with that one. You don't have to do that computation again. So that's going to be a 4 right there. All right, so negative B, B is 4. Plus or minus the square root of this 4 over 2 times A. So for this quadratic formula, I'm only plugging in B and A, and then instead of plugging in A, B, and C over here, I'm saying, hey, I already did that computation. If you wanted to do it again, just for a good time, who am I to stop you? Go for it. But I'm just showing you that you already did this, you already got that number, so just, you know, save yourself some trouble. All right, let's simplify this. That one's going to stay a negative. Last time it changed because there was a negative of a negative. The square root of 4, that's nice, right? That's just going to be 2. And then 2 times 1 is going to be 2. So we get that this simplifies into negative 4 plus or minus 2 over 2. Now you could do this a couple of ways. I chose to simplify it like I did the last one, and just break this apart into 2 fractions. Negative 4 over 2 plus or minus 2 over 2. And then simplify them. You could have also chosen to simplify the top and then divide it by 2 if you wanted to, but that is a little bit messier. So I figured I would just try to be consistent with how I do things. Certainly if you guys have different ways of doing it than I do, I want you guys to do what works with your brain. Okay, so this is going to be a negative 2. This is going to simplify to be 1. So I get negative 2 plus or minus 1. These are going to give me my 2 solutions. So remember that plus or minus business, how that splits into plus and minus. So I have 2 computations. I have to do negative 2 plus 1 and then negative 2 minus 1. So there's my 2 solutions, negative 1 and negative 3. So I in fact did get 2 real number solutions. Again, these are real numbers because they're not imaginary. Okay. Moving on along, just to show you guys some other examples of these. Pause the video, find A, B, and C, find the discriminant, play along. Don't just watch, okay? Watching's not going to be enough. You guys actually need to practice this before you see what I'm doing so that if you are going to make any mistakes, you can find them and fix them early. All right, so A, B, and C. 1, 14, 49. Discriminant. Let's do some plugging and chugging. You get 0. Ooh, we like 0. You'd like to see 0 as a discriminant, trust me, because that means you're only going to have one real number solution. Now I'm going to show you why that's the case. So we bust out the quadratic formula, we take that discriminant of 0, we plug in 14 for B, and 1 right there for A. And now we're just left to simplify this business. All right, so we get negative 14 plus or minus, what's the square root of 0? That's just 0. 2 times 1 is just 2. All right, so doing the same thing, just trying to be consistent with how I do things for you. I'm going to split this apart into 2 fractions. Negative 14 over 2 plus or minus 0 over 2. All right, let's simplify that a little bit more. That's negative 7 plus or minus 0. So if I split that into those 2 separate solutions, you can see what happens, right? I end up having to add 0 and then subtract 0. That's the same thing. Whether you add or subtract 0, it doesn't change the answer. So that's how I get the same answer twice, or what's called a repeated root, or a repeated solution. So that's why we say that 0 has one real number solution. Even though it technically has 2 solutions, it's, the same number twice. Yeah. All right. So you may have noticed that the first few examples that I did had an A value of 1. When we move away from that leading coefficient of 1, things start getting messier. Right? We start getting a little bit more complicated of an expression to have to simplify. But our process is going to be the same. So we have a calculator to help us if we get stuck. Pause the video, label A, B, and C, find the discriminant, tell me how many solutions you're going to have. Now, first with this one, if you labeled A, B, and C, straight from this, ooh, not good, because this is not in standard form. So we need to rewrite it in standard form first. Then we can see that A is 6, B is 2, and C is negative 20. All right. Now, if Hawks doesn't ask for the discriminant, you can just jump straight to the quadratic formula. Some of the ones in the beginning of the certify may ask for the discriminant, and sometimes they may just say, here, just go straight to it. Solve and give me the answers. If it doesn't ask for the discriminant, you don't have to. But if you want to, if you just kind of get into that zone and you're like, okay, I like finding that as like kind of doing like a little side work or something, go for it. I'm just going to jump straight to the quadratic formula. So we know what A, B, and C are. So some plug and chug happening here. Okay, so from here to here, I'm just plugging in those values of A, B, and C. Now I need to simplify this. So that stuff under the radical, called the discriminant, is this, let me scooch this over a little bit, 2 squared minus 4 times 6 times negative 20. You can do that computation all at once on the calculator, and I get a discriminant of 484. So I simplified the stuff under the radical. I simplified that discriminant to be 484. This 12 came from 2 times 6. All right, let's check out 484. Is that a perfect square root? Let's see. It is. Square root of 484 is 22. Nice. So then I can simplify this into negative 2 plus or minus 22. Drop the square root. After you take the square root of it, don't write the square root again. Over 12. Now I'm starting to shortcut this a little bit so we don't have to write quite as much. So I'm still splitting these apart into two fractions. Okay? But the way I'm doing it, I'm just continuing to write it as 1, if that makes any sense. So let me kind of erase that a little bit. So rather than split it up into two fractions, I just kind of wanted to give you a slightly different version. I mentioned this earlier, but you know, in the beginning when I first start doing the examples, I like to keep it consistent. And then maybe once you get comfortable with it, then I'm like, oh, what if we did this? You know. So what if, instead of splitting it up into two fractions, what if I just split up the top into its two separate components and left that 12 on the bottom? So watch what happens. I get negative 2 plus 22, which is 20, over 12. You can put that in your calculator. That'll reduce it to be 5/3. And then negative 2 minus 22 over 12 will give me negative 24 over 12, which simplifies to be negative 2. So the difference being that I didn't bother splitting this into two fractions and then adding and subtracting those two fractions. I just left it together. You could have done that back here as well. Sorry, not right there. Like back here, I could have just done negative 4 plus 2 all over 2 and negative 4 minus 2 all over 2. So I could have done that as well. Okie dokie. Moving on along here. So you can see this one is not in standard form. So let's go ahead and get it in standard form first. Then let's label A, B, and C. Plug them into the quadratic formula. See where the day takes us. So rewriting this in standard form, I'm going to move that 8x and that 9, or sorry, that minus 8x and that minus 9 to the other side. Then we get that A is 2, B is 8, C is 9. There's my quadratic formula. I'm about to do some plugging and chugging. So this discriminant over here, that 8 squared minus 4 times 2 times 9, you can just put that into your calculator. Don't put the square root in there yet. Okay? Just do the discriminant. Just do the 8 squared minus 4 times 2 times 9. So 8 squared minus 4 times 2 times 9, you get negative 8. So there's my discriminant. All right, look at that number. See that negative under that square root? We're going to have two imaginary solutions. So I'm going to go ahead and pull that negative out as an I. Now the square root of 8 is going to split into this 4 and 2 business, and it's going to simplify into 2 root 2. Of course, if you don't see that that's going to happen, you can just do the square root of 8 on your calculator and get 2 root 2. Now where did this 4 come from? It came from that 2a business. All right, so this becomes negative 8 plus or minus I and then 2 root 2. There's the square root of 8 business over 4. Now, sometimes you have to split these up into two fractions. Okay? Sometimes you don't, but sometimes you do. So remember how I was doing that, and then the last example I didn't? Well, with these, you pretty much have to, because these aren't like terms, so you're not going to be able to combine them. So if either of these fractions reduce, you're going to need to reduce them separately. So with some of the other ones, I wouldn't bother splitting these into fractions if these were like terms up top. All right, so if I split this into two fractions, I get negative 8 over 4 plus or minus I 2 root 2 over 4. All right, and then we can do some simplifying. This 8 over 4 is going to be 2, and remember it was a negative. This 2 goes into that 4 2 times. So what happens to this 2 up here? Well, it becomes a 1, which we don't have to write. So we get this. Don't go trying to cancel out that 2 and that 2. That one's under a radical. So you can't cancel something under a radical with something that's not under a radical. Okie Okie dokie here. Last one. And this one's in standard form. Ooh, might be nice if you see it. This one's in standard form for us. So, boom. A is 1, B is -5, C is 7. There's quadratic formula. So we do some plug and chug in here. That red stuff, if you want to do that on your calculator, you get -3. So this negative times a negative, or the opposite of that negative, is a positive. There's your plus or minus. This discriminant simplified to be -3, square root still there. And then 2 times 1 is 2. All right, we're going to have an imaginary number because of that negative under that square root. So we get 5 plus or minus I, and then we get the square root of 3 over 2. This isn't going to simplify any further, right? Like the last one, you had to split them up and then do some reducing and stuff. I don't have to worry about that because I can look at this and see 5 over 2, not going to reduce. I root 3 over 2, not going to reduce. Root 3 doesn't simplify any further. So we don't have to worry about, rewriting this in order for it to simplify. So I wanted to do one like this just to show you that you don't always have to split these up. It's just only if it's going to simplify any further, be it the radical or the fractions, simplifying or anything like that. So I just wanted to show you if I split it apart, you get the same 2 answers. So I put a minus there by accident. Oops. All right, so that concludes section 10.2.